This is Mastering Mathematics with your teacher, Karen Weston.
Hello, Antigua Barbuda. Welcome once again to this, another in the series, Mastering Mathematics. My name is Karen Weston, and this is a program sponsored on behalf of the Ministry of Education using its EBU unit, the Mathematics Education Center for Research and Warrior Education, and ABS Television. And again, we are going to make certain that mathematics is a doorstep experience and that the entire Antigua populace will know mathematics. No one will point a finger and say again, in Antigua, we don't know mathematics. So, we're taking you from the basic. No secondary school child will ever have to say, when I was in primary school, we did this, but I don't understand it. Again, there's a little hole in our hearts as we remember our fallen brother, Sean Williams. We will always take him around with us. And I hope that this, his last memory here on God's earth, in terms of his production to mathematics, will take him to that safe, eternal home that God has promised for all those who believe in him. We also want to assure the family that God has said, I will be with you. I will take care of you. So, what human beings have done, God will rectify. Let us rest in the assurance that there will be eternal peace and joy for our son who has left us too soon, we would say. But with God, all things are possible, and we know he will make it right for us. And we will continue our task here and dedicate every last piece of work that we have to do to the memory of Sean Williams. To my students from Old Road Secondary, as I said just after the independence, I will be out to see you. Your projects will be all right because your teacher was a forward-thinking master, and he has already said to me exactly what he thought he was going to do this year. So that will be taken care of. Thank you very much to the staff, and please keep the fort going. And remember that with God, all things are possible. Today, we are back where we left you the last time. What did we say we were doing? Do you remember the topic that we are actually studying? Oh, yes, because we're so enthusiastic, we're not going to let anything slide. And so it is our fractions. We told you about the different families, the different sons and daughters that are members of this family fraction. We spoke about vulgar fraction, mixed fraction, improper fraction, equivalent fraction, and tell you later we will take you into our far cousin, the decimal fractions. We left you where we started looking at equivalent fractions because I knew we would have been coming into the operations, and equivalent fraction is actually at the foundation of what we're going to do in terms of adding and subtracting fractions. Today, I hope to take you, and tomorrow to take you into that aspect where we'll be looking at adding just vulgar fractions. Do not mix another type, especially our mixed fractions, with this aspect of it. Think about it as a completely new concept and make certain that our students understand what they are doing and why. If in your classroom you have time, remember to bring the practical aspect to it. Nothing fancy, a piece of cardboard, a piece of paper, and all this can do the task. Last time we told you that equivalent fraction, we can either get them by given any fraction that we are given. We can multiply the numerator and the denominator by the same number, and we will get a fraction that has the same value, although looking differently, and that is what we're going to be calling equivalent fractions. And so we said that half would be equal to 5 over 10 is the same as the fraction 4 over 8. All right? And you would see right away what makes it that. We have a common term, half. Half. All right? Do not forget, we said again, the role that language plays in the mathematics classroom. Then we went on and we gave you the exercise of seeing if we could actually get a fraction that we would be saying we are reducing. All right? And if we're reducing fractions, we are saying they still have the same value, but they will be represented by different numbers. We say when we use that word reduce, the mathematical operation associated with it is division. All right. Now, I sent you home the last time and I said to you, match me in terms of saying I have done for you 8 over 10 and said that the equivalent fraction would have been 4 over 5. So I gave you 9 over 12 and asked you to provide me with the equivalent fraction for this one. And again, we're saying specifically that we are reducing. And in terms of reducing a fraction to get the equivalent of it, we must multiply the numerator and the denominator by the same whole number, because it can be fraction, it can be anything, but it must be the same number. Do we remember what a numerator means? What the denominator means? What part of the fraction we are referring to when we talk about numerator and denominator? Teachers, do not take it for granted that every single child in that classroom remembers. So before we get into our lesson, we do our quick revision every time so that everybody's with us and we know that they are on the same page. We know that they know the top number in the fraction is called the numerator and the bottom number is called the denominator. What are the functions? The denominator tells us how many parts we're dividing the whole into, and the whole does not mean it has to start from one unitary stuff. It can be 12 marbles, 12 eggs, 12 mangoes, 12 sweets, but the numerator now tells us how many of these we are engaging. And we're saying we're taking 9 out of the 12. 9 parts, equal parts out of the 12. And that is why we are interested in terms of this word fraction, because we know that normally in Antigua, we can just say, give us a piece of bread, give us a piece of something. But we want to use the term fraction to indicate that we are calling for equal pieces. All right? So that is where we are going to be doing things, still using pieces, still using portions, but it is equal pieces, equal portions. What did you do for this one? Do I hear you telling me? I see a little hand shutting up in the air. What you said you did? All right, you can't wait. You're telling your granny, move, move, move. Yes. So tell me what you did. I'm listening to hear that answer. Yes, you know your 3 times table. So you know that 9 and 12 came from that 3 times table. So you did what? Right, you divided numerator and denominator by 3. So this is what we had, okay? So this would have been 9 divided by 3, and it is also 12 divided by 3. So what do we know about that? When we divide 9 by 3, which number in that table would have given us a 9? 3 times what would have given us 9? Did I hear you telling me that answer? Does Aisha know the answer to this question? 3 times what would have given me 9. And she likes to stay in the background and just mouth. I don't know if she doesn't think her children want to hear her voice on the television, and then just writing it for me. Yes, 3 divided by 9 would leave me with a 3. And then again, I'm asking, what times 3 would have given us 12? A lovely, nice dress, a green, a pink, so beautiful. But Aisha does not want to face the camera. 3 divided by 12 divided by 3, and again the answer would be, and she says quietly, she must have named Dummy Arthur, you know? Right, so the answer would be 4. And that is what, so did I hear, did you hear them, Jetta? A whole chime of children jumping up and saying, yay, they got it. All right, teachers, enjoy the chance, enjoy the children's joy. All right, so they know what they're doing, they're reducing. All right, it's like somebody we know, she's reducing. She doesn't want to be a chubby old fat person, okay? So she's eating her vegetables and so forth. And it's the same thing we're doing when we start talking about our fractions, okay? So that is right. Okay, now, so a big, and give them their text, you know, and with red ink pen. They want to see it in red. Give them in red. Don't matter who tell you don't use the red. That's what they want to see. All right? And if you're lucky to, give them a face with it, because they love that. When they see a face here and they see that big smile. And if you can draw properly, you have your hands here and you're clapping. All right? So they can see you clapping them on. Okay. So that is what makes the children come alive. So you don't have to buy anything fancy. These little things let them feel happy. And the last one we gave you was 4 over 16. 4 over 16. And what are you telling me? You're saying, Miss Weston, you must be crazy. You don't know we know that? I know 2 times something will give me 4. But when you put 16 with it, I went to my 4 times table, and I know 4 ones are 4. But what times 4 would give you 16? Do we know this one again? Are we hearing them? Are they talking? Jetta, can you hear them? What are they screaming and saying? All right. And we can hear the answer coming up. I think I'm going to have my little child right at the end there, not sitting with Aisha, because she's making her camera shy. She will be on the telly and telling them what the answer is. Okay? So again, yes, we're going to be dividing numerator by 4 and denominator by 4. And we're looking for answer. So when we say 4 divided by 4, what number times 4 would give us 4 for the answer? What is the answer? Ah, yes, they're screaming. 4 times 1, and it's over. And again, you've told me already, 16 divided by 4, the answer is 4. And that is what we are doing when we do something like that. Parents, grannies, uncles, do not forget. Just keep practicing and showing them these tables, okay? Let them use it as a tool. Nothing to be sitting down. Reward them. Give them a little sweet. Give them a piece of the sugar cake. Buy something. Give them 1 more chicken wing, right? It's because they've gotten a big work today. Another spoonful of rice or a dumpling. See what they like. And these little rewards are important. You're not bribing them, but you're rewarding them, showing them that the value of their work will always bring good compensation. Now, I'm going to send you on a little break, let you cool down a bit, because I'm going to take you into the first operation in terms of how we will be now not just reducing equivalent fractions, but how we will apply that arithmetical operation of addition to these fractions. So take your little break and we'll be right back to take you through some more fractions, and this time we will be adding vulgar fractions or proper fractions. See you in a minute.
Carefully read over the sections of your textbook assigned by your teacher. and look carefully at the sample problems. Decide if you benefit more by reading before or after the instructor covers the material.
All right, so I hope you had a good break and you're relaxed now, because I'm going to show you something that we call, if I gave you whole numbers, let's just put you on, and this is what we call learning by association. If I gave you 2 plus 3, I have a little one in the studio here called Kasai. Kasai, 2 plus 3, what would I get for my answer?
6.
Oh, she's shy too because she's related to Aisha. Don't send your daughter near to Aisha, right? Aisha don't want them to be on the TV. Kasai, tell me again. What is it? What is the answer? 5. All right. So if we had the number 2 plus 3, we would have gotten 5 for our answer. Do you know that if I gave you the fraction, a half plus a third, we can also add that too. But because it's not whole numbers, we have to go into some operation. What do we have to do? And in the primary school, our teachers would say, so they would actually say, I have to teach them how to find LCMs of numbers. All right? I have to teach them how to find LCMs of numbers. Now, I am using an acronym, and I'm talking about LCM. And what does that mean? And it means lowest common, yes, common multiple. All right. So then, before we take you into addition of fractions, we are going to tell you we need a tool to use for this to happen. And the tool that we will be using is called the LCM, which is the lowest common multiple. How would we find? I am now dealing with the fraction, a half and a third. How would I find the lowest common multiple of the numbers in the denominator? Okay, so I am looking for the lowest common multiple of 2 and 3. Now notice that I am putting down something here. Oh, when I was in junior 3, I had a teacher called Teacher Hyson. You know her? Now she goes to TOR. She's at TOR. They call her Miss Rifo. But in my day, she was called Teacher Hyson, right? She taught us how to find these things. She taught us fraction from junior 1. We were in the government school, and I still remember. By the time I got to Sunnyside School, I was strong. Do not say that the public schools are not good. You even have more qualified teachers teaching in those schools today. All right, but just take time, take an interest in your children's occupation, and you will see that all can be well. These people, when they teach you something, you don't forget. You take it to your grave. All right, so this is how they're telling me, and it works all the time, and that is why I am using it. It works all the time. There's some shorthand method that we call modern day style of getting into this, but I have used some of them, and in 3 weeks I've forgotten them. I never forget how to do it using this method, and this is the one I want to pass on to you. So we take the denominators and we put them in our side work. So you write 2, you put a dot there, and you write 3. Our lowest common multiple would have been our 2 times table. Okay, I tried to get Kasai to say this 2 times table for me, but again, she's related to Aisha, so she's shy, not coming on the television. Okay, are you ready now to come and tell me your 2 times table? she's still making up her mind. So while she's making up her mind, let's get on here. What we do, we start from the lowest common multiple, and then we start and looking and saying what can be divided by the numbers we have. So we start with 2. Can 2 go into any of the numbers we have? We say yes. We can get 2 into 2 goes once. So we put a 1 here. 2 cannot go into 3 without leaving a remainder. So we just bring down the whole number 3. And remember, again, we are examining numbers. And we know that 2 is an even number, 3 an odd number. So we know that 2 would not be divided exactly without leaving a remainder. So we have gone 2 into 2 goes once, and bring down our 3 because we can't use it. Okay, once we look at our second line, we see that we have only one number to look after, and that is the number 3. Because once we're dividing the numbers by the different multiples, our aim is to get 1 in the last line. Okay? So we don't have to try with our 2 again because we have already achieved our goal that it is now 1. Alright? So we look at the second number that we have, and it is 3. So, of course, we're going to use our 3 times table. And we're looking to see what we're going to achieve here. So the next one we're using would be 3, and then we're just bringing down our 1, and then we're saying 3 into this 3 goes once. Okay, and once we would have gotten ones in our last line, that is the end for finding the LCM. Alright, our aim all the time is to get 1. Here we are finding the LCM. Once we would have gotten to this point, we look at the numbers we're using on the side, and so we multiply them to get the product, and the product of the numbers that we have on the side would give us our LCM. So we're looking here and saying the LCM for those 2 number fractions that we want to add would be 2 times 3. And we know 2 times 3 would give us what, Cassie? What's the answer? 6. All right. You have to keep away from Aisha, you know. You have to come like Auntie Karen, right? And don't be camera shy. Okay, because knowledge is always powerful, okay? Keep with Auntie Karen, and then you won't fray the camera. Okay, so the answer would be equal to 6. So our LCM over here, when we're going to do our addition, would be 6. We're not talking about the addition as yet, because I'm going to tell you what is the whole idea between finding that LCM 6. Take some time, teachers, cool down. Yes, the lesson is about adding fractions, but we have to go and construct a tool to use with the addition of fractions. So what do? We call it a little aside, and so we have to teach them how to find the LCM because we're going to use it. So the first thing we want to bring to their attention is that whatever number they have in the denominators, they're going to set it up like this. So you're putting them 2 and we had 3. And then you see our tables come in once again, and we're starting from our lowest one, which is our 2 times table. And any number that 2 can be divided by, we're going to attack those, and the others which 2 cannot go into without leaving a remainder, we just bring down wholesale. All right, and that is how we're going to find the LCM. What are we aiming for? We're going to teach you how to do the addition. But before that, we cannot move on straight to doing addition without making certain that you know how to find the LCM. Wow, I showed you how to do one. Do you believe that you can construct some fractions for yourself and try some LCMs so that tomorrow I can take you on to the addition itself? You're enthused, right? So you saw what we did here. I had the fraction 1/2 plus 1/3. So we took the denominator, which is the 2, the denominators. So we had the 2 and the 3. And first of all, we had to find the LCM. And this is our little working box over here. And we said to find the LCM, we have to set it up like this, starting from our lowest table, which would be the 2 times, and we're dividing until we get our last line to be 1. Okay? When that happens, we multiply the numbers on the side to give us a product. Okay? So do we know, we remember that word product? That is why we have to know all of them. So the product gives us the answers from the numbers that we had to use to find the LCM. And now we can come back and say the LCM for adding 1/2 plus 1/3 would be 6. We draw our line. We have different names for these lines. I think the line that divides the fraction, the numerator and the denominator, they give it a fancy name of a vinculum. But we're not going to bother you with that. We're just drawing our lines right now. And so we have the LCM here to help us in our addition. But before we go into the operation, we're going to spend some time to make certain that our students can find LCM of arbitrary fractions. We will start taking you through again how we find the LCM, and then we'll talk about the addition of fractions. But our session for today has come to an end. You see how I'm dressed in the lovely colors of the national flag? All right, because what do we know? At the end of this week, on Friday, near the weekend, 1st of November, we will be celebrating our 32nd independence, all right? And it has been done under the theme, Antigua and Barbuda, one family, celebrating with pride, vision, and integrity. Hear it again. Antigua and Barbuda, one family, celebrating with pride, vision, and integrity. And I want to say, we are going to make our students creative, innovative individuals able to help with this vision and integrity. So today we ask you to remember again our state of Antigua Barbuda as we cement our place in the world and in the large economies to make certain that we too, although in a third world environment, can produce first world citizens. So do enjoy the rest of the evening, and tomorrow we will be back to take you through some more of the operations where we are aiming to get right into addition of fractions. Have a good evening, everyone.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and the ABS TV.